हेलो स्टूडेंट्स, वेलकम यू ऑल वंस अगेन ऑन बिहाफ ऑफ रेजोनेंस। आज 10 तारीख की सेशन 2 में मेमोरी बेस्ड पेपर देख रहे हैं अपन। केमिस्ट्री, फिजिकल केमिस्ट्री के क्या क्वेश्चंस दिया है। द फर्स्ट क्वेश्चन, 0.02 मोलार एसिटिक एसिड हैज स्पेसिफिक कंडक्टेंस given as 5 into 10 power minus 5 Simon centimeter inverse, also given limiting molar conductance of acetic acid, that is 400 Simon centimeter square mole inverse. Therefore, the K for acetic acid is, it is application of Kohlrausch law, and lambda m molar conductance, it is K into 1000 by m. We can calculate, K value is given, molarity is given. On substituting, you will get lambda m as 2.5. And limiting molar conductance is given as 400 and molar conductance at a given concentration is 2.5. From the ratio we are getting the degree of dissociation alpha. Now, we know Ka equal to C alpha square upon 1 minus alpha. From this, on substituting alpha value, we are getting 8 into 10 power minus 7, and we have to report this as 8 because it is given in the quotient dash into 10 power minus 7. So, answer is 8. The next question, the correct order of metallic character of beryllium, calcium and potassium is, this is from S block elements. Here in this, from top to bottom, the metallic character is increasing, and alkali metals and alkaline earth metals, in these alkali metals are having more metallic character than alkaline earth metals. So, the correct order is potassium greater than calcium greater than beryllium. This is the question from coordination. As usual, we are getting the complex and the CFSE calculation, and CFSE can be calculated by using this formula minus 0.4 n T2G plus 0.6 n EG delta naught plus MP. Here n T2G means number of electrons in T2G orbitals, and n EG means number of electrons in EG set of orbitals, and MP means pairing energy. Here in the given complexes, the ligands are water, that is weak field ligand. So, there will be no pairing energy, and in this if you calculate the CFSE, in the first complex titanium is in +2 state and it is in 3D2 configuration. So, T2G 110 EG 00 configuration you can observe according to CFSE crystal field theory, and CFSE can be calculated by putting n T2G means number of electrons in T2G set are 2, that can be equal to minus 0.8 delta naught, and vanadium is also in +2 state 3D3 configuration T2G 111, and on putting the number of electrons of T2G you will get minus 1.2 delta O. And the third complex Mn is in +3 state, and Mn +3 state it is having 3D4 configuration. Since it is the weak field ligand, the configuration is T2G 111 EG10, and there is 3 electrons in T2G set and 1 electron in EG set of orbitals, and by putting these here T2G as 3 and EG electrons as 1, we will get minus 1.2 plus 0.6 delta O, and on calculation you will get minus 0.6 delta O. And iron here is in +3 state, in presence of weak field ligand it has 3D5 configuration and T2G 111 EG11, and by substituting the number of electrons 3 and 2 on calculation you will get CFSE as 0. So, on matching, first one will have minus 0.8 delta O, second one will have minus 1.2 delta O, and third one is having minus 0.6 delta O, fourth one is 0 delta O. So, the first option is the correct answer. The next question, assertion higher energy required for conversion of magnesium to Mg2 plus than that for magnesium to Mg plus. Reason, Mg2 plus has small size and more charge. So, this is from periodic table, this is related to ionization enthalpy, and we know from magnesium to magnesium plus, one electron is to be removed. This is called first ionization enthalpy, and to convert magnesium to magnesium 2 plus, 2 electrons to be removed, and the second ionization enthalpy is more than that of first ionization enthalpy because of more effective nuclear charge. That is why here the assertion given is higher energy required for conversion of magnesium to magnesium 2 plus than that for magnesium to magnesium plus. It is correct, and reason magnesium 2 plus has small size and more charge. This is also correct, but it is not the correct explanation. Next one, mole concept related question, very easy question. 16 gram methane, 2 mole of nitrogen, half mole of hydrogen, half mole of SO2 are given, and we have to match this with mass and volume. Here 16 gram of methane means 1 mole and volume is 22.4 liter. Mass of nitrogen is given, that is 2 mole of nitrogen means 56 gram and volume is 44.8 liter. Mass of hydrogen 1 gram and volume of hydrogen at STP is 11.2 liter. Mass of sulfur dioxide is half mole, sulfur dioxide is half into 64, that is 32 gram, volume of SO2 is 11.2 liter. On matching, you will get the first one is having 22.4 liter, the second one 2 moles of nitrogen is having 56 gram, and third one half mole of hydrogen has 11.2 liter and half mole of SO2 32 gram. Sorry. The magnetic moment of an ion is 4.9 bm. Find the number of unpaired electrons. The magnetic moment can be calculated by this formula, root over n into n plus 2 equal to 4.9 bm. And it can also be written as root over n into n plus 2 bm can be approximately taken as n plus 0.84 bm, and it will be equal to 4.9 bm, and you can write it as 4 plus 0.9 bm. That means n value can be 4. So, on solving this, you also get number of unpaired electrons 4. Next, the relation between radius of the lattice and edge length A of an FCC and BCC is. So, the edge length for FCC is A equal to 2 root 2 r, and for BCC it is root 3a by root 3a equal to 4 r. So, the direct formula, this is the relation between edge length and radius. Next question, this is from hydrogen. Isotopes of hydrogen have different physical properties. Yes, it is correct. Isotopes of hydrogen have very large mass difference. So, because of this only they have different physical properties. So, this is the correct explanation. Both assertion and reason are correct and correct explanation. Next, how many electrons are gained by MnO4 minus in strongly alkaline medium? In strong alkaline medium, MnO4 minus is converting into MnO4 minus by gaining 1 electron. So, answer is 1. The next question, consider a mixture of 2 moles of oxygen, 4 moles of neon gas, neglect any vibrational degrees of freedom. The total internal energy of the system is XRT. The value of X is, here the internal energy can be related to degrees of freedom as F by 2 nRT. Here the translational degrees of freedom, rotational degrees of freedom for O2 and neon gas are 5 and 3. So, the total degrees of freedom for O2 is, the total degrees of freedom is 5 and for neon it is 3. Now, if you calculate the total internal energy by putting these degrees of freedom, you will get 11 RT. So, answer is 11 because it is given as XRT and here X can be 11. Next question, For a first order reaction, if the value of T half is T, then the value of T 7 by 8 will be x T. Find x. Here T half is given as T and T 7 by 8, that means it can be T 87.5%. This T 87.5% and T half are related as 3 into T half. Now, here this is related as 3 into T half. So, x can be 3. Next, how many of the following have two lone pairs XCF4, N2, CO, CO2, NO and H2O? Here XCF4 is having two lone pairs, N2 is also having two lone pairs, CO is having two lone pairs, CO2 is not having two lone pairs, NO is not having two lone pairs, H2O has two lone pairs. So, 1, 2, 3, 3 species are having, 3 molecules are having the two lone pairs. So, answer can be 3. Next question from thermodynamics, number of endothermic reactions among the following is, here 2 HCl is giving H2 plus Cl2, the bond dissociation is always endothermic reaction, and H2O liquid to H2O gas, here the liquid is converting into vapor, it is also endothermic reaction. Dissolution of ammonium chloride. So, ammonium chloride when dissolved in water, it is an endothermic reaction. I2 is converting into I, here also bond dissociation, it is also endothermic reaction. C plus O2 gives CO2, the combustion of carbon, it is an exothermic reaction, except the fifth one, the remaining 4 are endothermic reactions. So, answer is 4. The last one only exothermic reaction, heat energy is released. In the remaining 4, heat energy is absorbed. During bleeding from a cut, FeCl3 is used to stop bleeding as, here in the FeCl3, blood is a negatively charged colloid. So, in the FeCl3, Fe plus 3 ion can act as the coagulating agent. So, the answer is ferric ion causes coagulation. Next, the correct order of magnetic moment of the given compounds is, the first complex nickel tetracarbonyl, in this nickel is in 0 oxidation state and it has 3D10 configuration, 3D84S2 can be adjusted to give 3D10 configuration because it is in the strong field ligand. So, magnetic moment can be 0. And in COF6 3 oxidation number of cobalt is plus 3, cobalt plus 3 has 3D6 configuration, T2G211 EZ11 because fluoride ion is the weak field ligand, and magnetic moment can be root over 24 bm. And iron in plus 3 state in with fluoride ion is also a weak field ligand, oxidation number of iron is in plus 3 state and 3D5 configuration T2G111 EZ11 configuration, and mu will be equal to root over 35 bm because 5 unpaired electrons. Here there is 4 unpaired electrons, so root over 24 bm. And here in this water is also weak field ligand, chromium is in plus 3 state, and in the plus 3 state T2G111 EZ 0, and here magnetic moment can be root over 51 bm, and the correct order of magnetic moment can be C greater than, B greater than, D greater than A. Water of crystallization in soda ash and washing soda is respectively. Soda ash means anhydrous Na2CO3, washing soda is Na2CO3 10H2O, and here this is 0 and 10. So, answer is 0 and 10, first one. Okay. Okay students, that is it for today and we will meet again in the next paper. Thank you.